Hi, welcome back to LeetCode. So in this video, I'm going to discuss LeetCode problem 3598, longest common prefix between adjacent strings after removals. So you are given an array of strings words for each index I in the range 0 to n-1. Perform the following steps. Remove the element at index I from the words array and compute the length of the longest common prefix among all adjacent pairs in the modified array. So that means, suppose for this example one, we actually have array of strings. So first is jump, then run, then again run, jump, run. So what they are trying to say, first of all, for answer 0, we will remove the word that actually present in the index 0. That means this will not be present. So then the modified array will be what? Run, run, jump, run. Correct? Now we have to compute what? The max, first of all, compute all common prefix of only adjacent pairs. Okay, adjacent pair. So here adjacent pairs are run and run. This is one. Another pair is this run and jump. Another adjacent pair is jump and run. Okay. So for this first pair run and run, so what is the length of longest common prefix will be what? Length will be 3 because run and run both actually equal, so length is 3. Next, for this pair run and jump, what is the length of the common longest common prefix? So run and jump. So here there is no common prefix, so the length will be 0. Correct? Here the length is 3, here is 0, and for this jump and run again it will be 0. So out of all of these adjacent pairs, what is the maximum length? I got 3. So that's why index 0, answer 0 will be 3. Got it? So you can see that answer is 3. Now for the next index, I will first remove this run. So our modified array will be look like jump, run, jump, run. Now what have to do? We have to calculate the longest common prefix all of the adjacent pairs. So that means first adjacent pair is jump and run, then run and jump, then jump and run. So for jump and run, what is the length of the longest common prefix? This is 0. So there is no common character present in the prefix of the string. So run and jump again 0. This jump and run again 0. Got it? So that's a for this index 1, the answer will be 0. Got it? Next, again, what have to do? First of all, remove this string, means run. Then the modified array will be jump, run, jump, run. So adjacent pairs are first. This is the first adjacent pair. Next, this is the adjacent pair. This is adjacent pair. So this jump and run, the adjacent pair. What is the longest common prefix? So this is 0. There is no common prefix. Similarly, for run and jump, again 0, and jump and run, there is again 0. Got it? So for this index 2, the answer is also 0 again. Now for the next index, first of all, remove this string jump. Then the modified array will look like jump, run, run, run. Jump, run, run, run. What should I have done? I have removed the third index that is present in index 3, 0, 1, 2, 3. So the modified string array will look like jump, run, run, and this run. Got it? Now for this adjacent pair, first adjacent pair, what is the longest common prefix? 0. There is no common prefix. For this run and run, length is 3. 3 actually common prefix. For this run and run, 3 is also length of the common prefix, longest common prefix. So ultimately, what is the maximum length? That is actually 3. So index 3, the answer will be again 3. Got it? Actually, answer is 3. So ultimately, what we are trying to do, we will actually have some input string. So S1, S2, S3, S4. Then what I have to do? First of all, I will remove this string. Then our modified array will look like S2, S3, S4 in this way. Then I will calculate the longest common prefix between all the adjacent pairs. Correct? That means I and I plus 1. Correct? This I and I plus 1. This is index 0, 1, 2. So index 0 and 1, then 1 and 2. These two actually adjacent pair are possible. And I will try to calculate what is actually the length of the longest common prefix. Now, how can I actually calculate the longest common prefix? So I actually have, suppose, two strings, one is S1 and S2. So X, Y, Z, another is suppose X, Y, Z, X, Y, A. So first of all, I will take two pointer. Longest common prefix means the substring, the prefix substring that is actually present in both the arrays. Correct. And if it is both the present, then we have to return that length of that subarray. So here actually X is also present. X is also present in the first position. Next, okay, shift this. So this is actually Y and Y. Okay, next position. You can actually just check also like the first substring actually XY, and the in the string S2 the substring or the prefix string substring of length 2 is XY. Both are actually equal. Okay. Next is actually XYZ. Actually XYA. Length is 3. Both are actually prefix. So is it actually equal? No. So that's why I will break from here. If it is not possible, do I need to check the other character also? The next character? Do not need, because this should be actually different. So it will not be matched if I take another. Suppose actually again another X. Here is also X. Will it be same? The substring? No, because one character is different in one position, so that it will be not equal. So I can actually break from that point of time. So what is the length of the common longest common prefix substring? That actually 2. Got it? I can easily find out that. So what I have to do, I will take two pointer. One is pointing in the string S1, another is pointing to string S2. So both are actually, suppose I is equal to 0. So I'll check that for the position 0 in both the strings actually equal character. Okay, so I'll go to the I equal to 1 next. Then actually okay, both are actually YY. Okay, next I'll go to 2. So both are actually equal. No, so I'll break from here. And what is the length of that? Length will be 2, maximum length of common prefix substring. Got it? In this way I can actually calculate. Now what actually ultimately trying to do? I will remove one string and I will create a new temporary modified array that will not contain this element S1. Okay, then again I will try to calculate 0 and 1, then 1 and 2 in this way. Correct. So what will time study for that? So I will remove each position S1, S2, then S3, S4. So there is n option. So first of all, for each position, like I can actually remove, I have to remove n elements like one by one. So if I remove suppose S1, then I will create a array of length n minus 1, and for that I will again call this to try to calculate the longest common prefix. So for that it will actually take again big of n roughly linearly. If I actually check all possible adjacent way, so it will take big of n square. This is clear. How to take big of n square? First is the number of options to remove. So there are n option. First I will remove S1, then I will remove S2, then I will remove S3. So in this actually, after removing S1, I will create a new array. This is the new temporary array S2, S3, S4, and for that I will try to calculate the check for each adjacent pair. What is the length of the longest common prefix? Correct. So for that it will take big of n again. So because actually here you can see that big of n minus 1 actually number of strings will be present in the temp array or the modified array. For that I actually can generate n minus 1 number of adjacent pairs. So actually here three S2, S3, S4, 3 strings present. So how many adjacent pair are possible? S2, S3 and S3, S4. So ultimately 2. So what is the n? 3 number of actually total string is present. How many actually adjacent pair are possible? 2. So that means n minus 1 number of adjacent pair are possible. Correct. So that's it will take actually again big of n to calculate each adjacent. I will try to check each adjacent pairs and I will try to find out that what is the length of the longest common prefix substring. Correct. And ultimately whatever the maximum length, I will store that. I will try to check that what is the maximum length longest common prefix substring, I will check what is the maximum length and will store that. Okay, so it will take big of n square. Now how can I actually optimize this? So let's see some observation. Suppose s1, s2, s3, s4. So I have removed s1. So our modified array will look like s2, s3, s4. Correct? So that means I want to check only s2, s3 and s3, s4. Correct? Next, suppose I have removed s2. Then our modified array will look like s1, s3, s4. So adjacent pair are possible, that actually s1, s3 and s3, s4. Correct? Now I have removed suppose s3. So then our modified array will look like s1, s2, s4. So adjacent pair are possible s1, s2 and s2, s4. Next, I have removed suppose s4. So the modified array will look like s1, s2, s3 and it will be s1, s2, another pair will be s2, s3. Clear? So that means when I remove the first element mean s1, so our pair is still actually same s2, s3, s3, s4. That means suppose this will I have removed the ith string. So I am actually going to do I plus 1 to I plus 2, then I plus 2 to I plus 3 in this way. Correct? Equivalent to this, if I don't want to create this new array, so it will be something like this. This is I plus 1, I plus 2 and this is I plus 3. So the new pair will be I plus 1 with I plus 2 and another pair will be I plus 2 to I plus 3. Clear? Next, this is actually our I, this is actually I minus 1, this is actually I plus 1 and this is I plus 2. So I have removed this ith character, ith string means s2. So what is the new actually string actually I have means what is the adjacent pair actually we are creating? That is here actually s1. s1 means I minus 1 and this s3 is I plus 1. Clear? And s3 is I plus 1 to I plus 2. And when I remove the string s3, that means this is now our current I. This means this is a current I, this is actually I plus 1, this is I minus 1, this is I minus 2. That means I have removed the ith string means s3 and now actually I have s1, s2, s4 means s1 and s2. s1 position is I minus 2 and s2 is I minus 1 and this s2 position is I minus 1 and s4 position is I plus 1. Clear? Next, I have removed the s4. Now this is actually our I, this is I minus 1, I minus 2, I minus 3. So here actually s1 means I minus 3 with I minus 2. Another pair is I minus 2 with I minus 1. Correct? So that means you just see the pattern that when I removed one string s1, it may be possible that we actually generating I plus 1, I plus 2, I plus 2, I plus 1 with I plus 2. I have removed the ith string. So another possible is I plus 1 and another with I plus 2. Okay. Another is I plus 2. This is actually possible I plus 2, I plus 3. Okay. Another situation possible that here when you remove the s2, the pair are possible is I minus 1 with I plus 1. First pair is I minus 1 with I plus 1. Another is I plus 1 with I plus 2. This is already I have written this pattern. When I remove the s3, what is I got? I got I minus 2 with I minus 1 and I minus 1 with I plus 1. Okay, I have already written it. Okay, next another pattern is I minus 2 with I minus 1. I minus 2 with I minus 1. So these different position are possible, right? So just see the pattern that when I remove the ith index, it is possible that I can actually generate one more pattern. This is the thing. Suppose A, B, C. Suppose I will remove A, then what will happen? So only pair will be B, C. So that's why I plus 1 with I plus 2. Got it? This is one case. Suppose I have removed B. So our modified array will contain AC ultimately. So this will be new pair. It will be created adjacent pair AC. So that's why it will be created this I minus 1 with I plus 1. If it is some element in the left side and some element in the right side of the removed string, so we can actually generate a new pair. So this is the newly introduced, newly added. This is clear. Why actually I minus 1 with I plus 1. This is actually I. This is actually I minus 1 and this is actually I plus 1. Adjacent pair previously was A B. Another was actually B C. But I have removed B. So that's why A and C is now actually adjacent. Clear? So that's why this pair may be actually present, may be created. So when it's to create it, when we have some element in the left side and some element in the right side. So I greater than 0 and I less than n minus 1, right? Then only it will be created. I minus 1 and I plus 1. Clear? Else another pair I plus 2 in comma I plus 3, it will be always present. Like here actually I have removed A, so I plus 2 means C and D. Suppose this will be anyway present, and I minus 2 comma I minus 1, that means I have removed suppose D, so I minus 2 means this is minus 1 minus 2, B and C, it will be present, correct? B and C pair. And I minus 2 comma I minus 1, that means this is I minus 2 minus 1 minus 2 and minus 1. This is actually clear, both are actually equal. This is actually duplicate. Okay, got it? So I have to think three situations. One is if I already calculate this, suppose I already know that what is the adjacent what is the longest count prefix for adjacent pairs for the inputs array B, C and C, D. Now suppose in ith index C, suppose I want to remove this C. Okay, so it will be present. I have to consider only A comma B and A comma B, then B comma D, and anything else no, correct? So that's why if I easily find out that if I remove this C, if I already store that what is the maximum length till this index and this till this index, if I don't want to calculate every time, so I can easily check that what is the maximum length. Suppose in till A1 I can say that till 0 to this string A, for the adjacent pair, what is the maximum length of longest common prefix substring. So suppose this is actually x1, and for this if I say that from n minus 1 to this string D, the maximum length of the long common prefix substring is suppose x2, then I can easily compare with x1 with x2, and if it is possible to create a new pair or not. So how it will be created? If a current character the position is greater than 0 and we actually some element in the right side, we actually some element in the left side and the some element in the right side. So then there will new pair will be present. So that time I have to calculate that. Means for this I will create a helper function. I will pass this. Suppose I have removed C, so I will pass this A. This B and C. B and D. I will pass between string B and D because this pair was not previously adjacent. Now it is after removing C, B and D now is adjacent. Got it? X1 actually X1 and X2. I have already stored that what is the length, maximum length for 0 to index I minus 2. Why I minus 2? Suppose A, B, C, D, E, F, G. Suppose I want to remove E. So this will I. Okay. So adjacent pair means A, B, B, C, C, D, D, E, E, F, F, G. So if I am trying to remove this E, okay, so D, E is possible? No. Why? Because E will be removed. So that's why I cannot consider this pair D and E. Can I actually consider this C and D? Yes. C and D both will be present. I am only removing E only. So that's why it only ending at this index C means A, B, B, C, C, D. This is the last pair actually I can actually have in the left side of the index I. So you can easily find out that what is the index. Here actually I index, suppose the starting index is 0, here actually starting index is 1, starting index is 2. So that means here actually I is the index 0, 1, 2, 3, 4. 4 minus 2. So index 2. So this is the rightmost adjacent pair actually I can actually have. Correct? So that's actually index 2. So I can easily check that till 0 to C, what is the maximum length of the common prefix substring? Okay, 0 to I minus 2. Got it? From the left side. And for the right side, what is I can do? Easily check that the valid EF pair will be valid. No, because E will be removed. So EF pair is not valid. F and G actually pair is valid. Yes. After removing E, still F and G pair will be valid. So that's why the nearest adjacent pair after removing E, it will be FG. So what is the starting index for F? The starting index will be I plus 1. Got it? So from the right side, if I somehow check that from I plus 1 to N minus 1, what is the maximum length of the long common prefix substring? So this is from left side, it will go up to I minus 2, and from the right side it will be go up to I plus 1. This is clear. The index why actually I minus 2 and why actually I plus 1 from the right side. This is clear. Now how can I do that? I can actually use the prefix and suffix array now. So that means I will check what is the suppose for index 0 I will actually calculate what is the maximum longest common prefix substring for A and B. Suppose in index 0 I actually have that, suppose x1. For index 1 actually I have stored for B and C. For B and C I have stored that, suppose x2. For C and D index 2 I have stored that x3. Got it? In this actually I have actually stored till n minus 1, sorry, n minus 2, because n is the length of the array, in the length of the array. And how many actually adjacent pair are possible? N minus 1. N minus 1 actually adjacent pair are possible. So in this I have actually stored for each 0 to n minus 1 what is the length of the longest common prefix for the adjacent pairs. Now prefix, how to use the prefix logic here. 1 minute. So prefix actually how can actually use? So for this example A, B, C, D, I will know that for this index what is the length, suppose x1. For B and C I know x2. For C and D I know x3. For D and I know x4. So if I want to know that for 0 to I what is the length of the maximum longest common prefix substring, so I will actually store that x1, it will be maximum of x1 and x2, then x1, x2, x3, In this maximum, actually I can store that from 0 to I. This is 0 to 0, 0 to 1, 0 to 2. In this I can store that. Correct. So now actually I actually have this again, answer 1, answer 2, answer 3, answer 4, and this will be 0 at the last index because there will be no pair for E, adjacent pair. Okay, this is for prefix, means I can actually easily say that from 0 to I, what is the maximum length for longest common prefix substring between all the pairs, all the adjacent pairs from 0 to I. Clear? Now for the similar way, I'll actually use the suffix also. Means I know that x4, x3, x2, x1. So for the last, our answer will be 0 because there is no adjacent pair. And for the next second last, the adjacent maximum length of the substring will be adjacent pair will be x4. Next it will be maximum of x3 and x4. There are two pair possible from this index. This actually n minus 1, this will be n minus 2, this will be n minus 3. So from n minus 3 there are two pair possible. One is CD, another will be DE. Correct. So that's a two value possible. So out of that I will store the maximum value because I want to know only the maximums length of the longest common prefix substring. I don't need to know all of them. I need to know only the maximum length. So that's why I'll store that from index n minus 3 initially I can go up to 0. Now I actually have the prefix and suffix. Now how can we use this array in our answer? How? Suppose now I want to remove I is equal to 3. So this will be 0, 1, 2, 3, 4 suppose, and this will be 0, 1, 2, 3, 4. So from the prefix array I have to use I minus 2, that what is the maximum length till I minus 2 index, and from the suffix I will use that till index I plus 1, what is the maximum length of that. So I will get from easily these two values, one for the prefix from 0 to I minus 2. Why actually I minus 2 I have already explained, and from the suffix array I can actually easily check from I plus 2 to n minus 1. I can easily find out that. So this is for already existing pairs. Now there may be possible that after removing one string, it may actually create another new pair. So for this A, B, C, I have removed B. So I will create a new pair AC. So I have to call, for this situation, I have to call this helper function that actually return the longest common prefix substring. So I will call A with A and C. Got it? So here actually we don't need to check all the position, left side, right side, and also you don't need to check the, like previously in the brute force approach, we were actually ultimately we are trying to calculate all the adjacent pairs. What is the maximum length of the prefix substring, right? Then we are actually taking the decision what is the maximum length and we store that. But here actually we already actually calculated that value, that what is the maximum length for 0 to I minus 0 to I. I can easily check that, and from the suffix array I can easily actually find out that what is the maximum length from index I to n minus 1. Correct. So for this, for each position, for each ith index position, actually I can actually do, I need to know I minus 2 for the prefix, from the prefix, and from the suffix I need to know the I plus 1. And this situation can be actually create one new pair, so that I have to calculate that. So it will ultimately, it will take constant time big of 1, and this will also take constant time big of 1, and this helper function to get the longest count prefix substring, so it will also take rough maximum big of n, but this is the worst case, meaning only for the new pair. Correct. So now what is the code? So if our length is less than equal to, so is it possible to create or get any longest common prefix substring? Not possible. So suppose if only one string is possible, suppose A. So if I remove this, so there is no string now. If I remove that, our string will be empty. So it will be now return 0 because there is no comparison. no string to compare, so I have to return 0. Suppose you actually have two character or two string only A, B. Suppose I have removed A. So after that the B will be present only. Now for this B, can actually compare, can actually create actually two adjacent pair. No, not possible, only one is present. So that time also I have to return 0. Got it? They mention that if there is no common, if no adjacent pairs remain or none is share a common prefix, then their answer should be 0. Here actually no one actually adjacent pair is present. Here also there is no adjacent pair is present. Correct? So that's why for this situation I have to return 0. So that's why if our length is less than equal to, return n of that number of times 0. But else what I have to do, I will calculate the length of the longest common prefix substring between all the adjacent pairs. So how many adjacent pairs are possible? 0 to n minus 2. So means I to I plus 1. One adjacent pair will be created. So that's why I'll start from I is equal to 0, I less than n minus 1, I plus plus. Okay. And adjacent of LCP I, it will be longest LCP, means this is a helper function. It will return it will take two strings, words I and words I plus 1, adjacent strings. What it? Index at index I and index I plus 1. So, and I'm storing the index I. That means 0th index will indicate that length of the longest common prefix substring between 0 and string 0 and string 1. Got it? Now what I have to do? After this for loop, I can actually easily check that for the each adjacent pair, what is the length of the longest common prefix substring. Correct? Now we need to do two things. One is to calculate the prefix prefix substring, and the suffix. So prefix, if I want to calculate the prefix substring, prefix so then for the index 0, it will be whatever the value, it will be 0. Adjacent LCP 0 index, because there is no previous maximum. But for index I 1 to I less than n, I actually have some previous pair, adjacent pair. So that's why for that I will also compare with the previous also. So prefix of index I, it will actually compare with the I minus 1 also, and the current LCP, current longest common prefix substring length. I'll compare both of them, because it will be possible the previous adjacent pair actually it will give more or the maximum length. So that's why I have to store that also, because easily I have to find out that I can easily say that from 0 to I what is the maximum length. Correct? So that's why I will compare also the I minus 1 also. Okay. And for the suffixed array that actually I want to generate, for the n minus 1 it will be 0. Why? Because there is no pair possible with n minus 1. Correct? There is no more character in the right side, so there is no adjacent pair actually possible. So that's why it will be 0. Now for n minus 2 to 0, this is from right to left I am actually traversing. So this is suffix array, right? So from right to left I am traversing, I am starting from n minus 2. That means one index is n minus 2, right? That will be adjacent of LCP I, and another will be I plus 1, that is present in the suffix of I plus 1. Got it? And out of that I will store take the maximum value and store the index I. So index I, suffix of index I can easily say that from index I to n minus 1, what is the maximum length of the common prefix substring. Correct? And from prefix of I can easily say that from 0 to I, what is the maximum length of the common prefix substring from 0 to I, and this is from I to n minus 1. Got it? What is the prefix and suffix here? Now what I have to do, I have to return a vector of integer answer. So I have taken this vector that I have to return, and I will actually iterate each position. I is equal to 0 to I less than n, because I have to remove each. Suppose first I will remove jump, then I will try to calculate what is the maximum length of the common prefix substring. So I will take the maximum value, so that's why I have taken a maximum variable. So it will be initialized to 0. So actually I have to check that is there any left pair is possible or not. Suppose I remove jump, so is there any possible to get any left side any pair, adjacent pair? Not possible. But suppose I have removed this index 2. So I actually have one pair possible, this jump and run, right? This will be a valid adjacent pair. So that's why I will check that if I minus 2 is greater than 0, greater than equals to 0, means A, B, C, D. So this is actually C. So after removing C, this BC valid pair will be invalid, right? Invalid. So the rightmost valid pair will be AB. So what is the position for A? This will be I minus 2. For B, it was I minus 1, but this I actually indicated that what is the length till I to I plus 1, right? I and I plus 1. So that's why I have to go this index I minus 2. Got it? So then actually I can actually compare with I minus 2 and I minus 1. I can generate that pair only. So that's why for the left side, I have to check that for if the I minus 2 greater than equals to 0, that means we have some pair in the left side. So if we actually have some pair, so I'll store the what is the maximum length. So I'll store the maximum variable with the maximum value of till now and the prefix of that I minus 2. Prefix of I minus 2, that means what? It will indicate ultimately till A comma B pair, right? I actually store 0. It will actually indicate that what is the length for A comma B, means I comma I plus 1, clear, in the prefix. So that's why I will store in the index I'll take value at the index I minus 2, got it? And else like this is for the left side, and from the right side is also possible. Suppose I have removed here actually B now, so B will be now removed. So rightmost from the right side, what is the nearest pair actually adjacent pair possible? That's actually CD. So what is the position for C? That actually I plus 1, and the adjacent pair will be I plus 1 with I plus 2, correct? So that's why I am able to take directly I plus 1. So that's why I am comparing with the suffix of I plus 1, got it? From I plus 1 to N minus 1. This is from left side and this is from right side, and it may possibly create a new pair. Here actually I have removed B, so new pair will be A and C. I have to calculate that also. I have to consider that situation also. So that's why if honestly it will be created if we have some element in the left side and some element in the right side. So that means I minus 1 greater than equals to 0. That means at least one element is present in the left side. I minus 1, because I have removed the ith character, and so it should be have some character in the left side. So that should be I minus 1 greater than equals to 0. And also I plus 1 less than n. And also one character should be present in the right side also of the current character. Current position is I. So I have removed I. So the next position of the right side will be I plus 1. So that position should be present. So that's why I plus 1 less than n. Then it will create a new pair. So that time I'll call this helper function and pass this what? That is a string is present in index I minus 1 and string is present in index I plus 1, because I string is removed. So the adjacent pair will be I minus 1, another string will be I plus 1. Got it? This is clear. And what are the maximum value I will get, that will be stored in the answer vector. And ultimately after checking all the position, means I 0th position, then first position, second string, third string, in this I remove all the string and I will check that and I will return the answer vector. Got it? So in this helper function, what is how are getting the longest common prefix substring? So I'll get what is the minimum length of the two input string. So and I am starting from I equal to 0. So here actually I less than n and both the character is present the same. Whatever the input string 1 and input string 2. If the same position, if both the characters are equal, so that means till now it is actually common prefix substring. So I'll continue I plus plus. Else if it is like it will break if they are both are actually not equal. So whatever I will have, that will indicate the length of the longest common prefix. Got it? So I hope this is clear, and I have shared this code in the description. You can check that. And if you found this video useful, please subscribe the channel and also like the video. Thank you. Bye.